Should be able to get through all this because this is probably my favorite chapter. I would not have ever said that when I first started teaching because I just didn't understand the heart very well, I don't think. And so it kind of freaked me out, but now it's probably my favorite. I think it's just really tangible. To me, it's easiest to see. Like it has a system, it like works a certain way. It's not like the nervous system where it's like, okay, I'm trying to imagine what the neurons look like what the nerve impulse looks like as it travels across. It's like the heart. You can see it. It's there. The blood goes here. It goes here. It's just really.
And then it messes up once and you're dead.
No.
True that.
Functions of the cardiovascular system. So this chapter is kind of long. We'll spend a good 2 weeks on this, just the heart and the blood vessels.
Why does it have a song?
Do what?
This chapter has a song. Or it says,
what?
You gotta have heart. Follow your heart. Oh no, it's just
I think they're just like saying quotes.
Are you supposed to give us the packet for this?
Oh, yeah.
Yeah.
No.
Oh, the PowerPoint.
Yeah.
I always get those PowerPoints and then they
pretty hefty chapter.
put them in my backpack and then I never see them again.
Well, I made it so you can write notes on it too. That's what made it really long. I'm gonna put these on
just lists.
Okay, so functions of the cardiovascular system. Oxygen transport, you know that, right? It moves oxygen around. Waste, carbon dioxide and waste removal. Body temperature regulation. How does it do that?
Say what?
How does it regulate our body temperature, the cardiovascular system? Cardiovascular, remember, is heart and blood vessels. Yeah, remember your blood vessels when you're
closer to the skin and further in.
Good. Look, y'all learned so much this year. Acid-base balance, so it helps to manage the pH of our blood. Okay, and it does that by oxygen and CO2 as well. Hormone transport, we know that we have to have hormones that move from one area to another through the bloodstream. And then immune function, it helps with immune function. White blood cells travel in there, go to the place where they need to go, and so forth. Okay. Anatomy and function of the cardiovascular system. These are some things that we'll look at. So the heart, going to this picture. Okay, think about kind of where your heart is. It's not probably quite as big as what you think. It's about the size of your fist. Okay, and let me get you guys, I can kind of share these. Maybe you guys can share one. Some of these have diseases, so
Thanks for giving me the disease.
Zach, you already have the disease.
Okay. I kind of helps to have to look at. All right, so a few kind of marks where you kind of see. Remember, the heart is in the mediastinum. It's in between the lungs. Okay, it's in the thoracic cavity, so it's in your chest cavity.
Oh, that's creepy. Nah, get that super close up.
Okay. The base of the heart is actually at the top of the heart. So this guy's missing the heart. But it's actually at the top. That's opposite of what you would think, but it's the wider portion. Okay. The apex of the heart is actually kind of the pointed part that points down towards like your left hip. Okay, but your heart really is in the center of your body. There's just like more of it on your left side. It's not, I know when we put our hand over our heart, we put it like way over here. That's not really where your heart is. It's more like in the middle. Okay, a little bit to the left. So that's that. So at the base of the heart is somewhere around the second rib. Your second, it's kind of hard to feel your ribs, but you can feel your collarbone. That's not your rib. It goes down from there. Second rib is about where the top of your heart is, and then the fifth rib. Okay. Do what?
I got too much fat. Feel my rib.
Not fat.
And then the apex is down around the fifth
Insulation.
rib. Okay.
Peek out from the bottom.
I guess you could try.
It's the only place
Yeah,
I'm
12. So It is above the diaphragm. What is your diaphragm?
Muscle has to breathe.
Muscle that makes your lungs go in and out. Right? It's between the lungs, about the size of a clenched fish, and weighs 8 to 12 ounces. Somewhere around there. Okay. Now you've got 4 chambers of your heart. So y'all open up your hearts. Okay.
Not.
Mine had surgery and it needs another surgery. Okay, so you've got your heart has 4 chambers, or chambers is just like a room. Okay, the 2 upper chambers, the ones at the top of the heart, are called the atria. Some of this is going to be repeat from last year's science. And then the 2 bottom ones are called ventricles. Atria and ventricles. Okay, the ventricles are larger. The walls of the ventricles are thicker. They have more muscle. The atria, and you'll see, they're kind of hard, actually, whenever we get up the sheep parts, the atria are kind of hard to even locate because they're really flat. They don't have a real muscular lining to them. They do, but it's just nothing like the ventricles do. Okay, now the right side of the heart, just remember when you're looking at these, you're always looking at their right, like you got to think of, whenever you think of it, it's always the patient's right and left. Okay, it's not when you're looking at it, that's not what you go by. And it's important that you get those 2 because blood goes a certain direction through there. Okay. The atria are low pressure chambers. They're kind of rooms. They collect the blood from other parts of the body, other areas of the body. And then the ventricles actually act as really powerful pumps. That's why the walls, if you'll notice in yours, you got the walls of the ventricles. See how thick they are? There's lots of muscle there. Okay, between the 2 sides of your heart, okay, between the right and left side, you've got what's called the septum. So you have an interatrial septum. Inter means what? Between. So interatrial septum would be where? Between the atria, right? Atrium is singular, atria is plural. So that's why you hear those 2. So the interventricular septum then would be between the ventricles, okay? Okay, the right side carries what kind of blood? Deoxygenated blood. The left side carries oxygenated blood. Okay, right side deoxygenated, left side oxygenated. That's because where does blood go in between the right and left side? Where does blood go in between? After it leaves the right side, it goes somewhere and then goes to the left side, to the lungs. Okay, picks up oxygen. Maybe think of one of the songs from my classes.
You don't still have those, do you?
Oh, yes.
So you have mine in cases?
No, I probably have it somewhere.
I don't remember how ours went.
We should watch those again.
Please play mine and Kelsey's, please.
I'll have to look and see if I can find it.
Kelsey didn't have to sing. I had to sing. Embarrassing.
Okay, the heart valves. Okay, so you've got 2 sets of heart valves. What are the valves? What do? They open and close. They let blood go through where it needs to, and they keep blood from backing up to where it doesn't need to be. Okay, so look, you've got 2 different types of valves. You have your atrioventricular valves. Where would you expect to find those? Atrioventricular. In between the atria and the ventricles. Okay, makes sense. AV valves. Those are the AV valves, between the atria and the ventricles. So those are the ones that kind of look like, those are the white, yes. Those are kind of the cusps of the valves, okay? Okay. Now these are connected, these little kind of stringy looking tendons, these are called chordae tendineae, and they're actually connected at the bottom to what's called papillary muscles. Okay, so they're kind of like the stringy looking ones, and you'll see they're really easy to see in the dissection next week. They're really easy to see. These little flaps that actually open and close are really thin pieces of tissue. Okay, the second type of valves that we have are the semilunar valves, and if you turn your heart up kind of like this, you can see them really well. They look like little doorways. The semilunar valves go towards arteries. Okay, that's what carries blood out of the heart. So the semilunar valves go into arteries. The AV valves are between the atria and the ventricles. Now, you've got two AV valves. The tricuspid, which is on the right side. When you look at the heart, okay, the right side of the heart, that's where this is the tricuspid valve. The left side, this is called the bicuspid or the mitral valve. Either one, bicuspid or mitral. I don't know, to me, tri always sounds like right, so that's how I remember that. I don't know why. You can remember how you want to. The book said to remember that that R and T are close to each other in the alphabet, and L and M are close to each other, like left and mitral. If you want to remember that way, that's fine too. Okay, so tricuspid's on the right, bicuspid and mitral's on the left. Okay, the semilunar valves, you've got two of those. Pulmonary one, where do you think it goes? To the lungs, goes to the pulmonary artery. Okay, and that one is the blue one on here because it's deoxygenated blood. Okay, the aortic valve goes into the aorta. Okay, and this one is kind of harder to find, especially in whenever we get out the hearts to dissect them, because kind of like rooted kind of back behind, but it crosses back behind the pulmonary artery. Okay, so those are the valves. Now the papillary with the AV valves, I'm talking about, basically the valves just try to keep blood from going backwards. It's called regurgitation. And so what happens is, for the AV valves, the heart contracts, okay, the ventricles contract, where they are. So the ventricles contract, and when they do that, they're putting a whole lot of pressure on the blood that's inside that chamber. So it has to go somewhere because it's pressing it out. Well, we want it to go through the pulmonary valve and the aortic valve so we can move on out of the heart. We don't want it to go back up into the atrium. So those papillary muscles contract, and they use those chordae tendineae to they contract and hold those doors closed, those AV valves, they hold them closed so that when all that pressure goes through and the ventricles pump and put that pressure through, they'll actually push out through the pulmonary and the aortic valve, and they won't go backwards back up into the atrium. Does that make sense? So that's why those muscles are there. It's like they've got ropes on them and they're like pulling them closed. All that pressure is going on. And it's just like a machine. I mean, your heart works like a machine. Pumps, it uses pressure to push open valves that need to be open and close other ones that don't, and so forth. Okay, real quick, tricuspid valve is, which of these?
First one.
Well, atrioventricular valve, tricuspid is an example of that. Which one's a semilunar valve?
Aortic.
Aortic. The location of the heart.
Thoracic cavity.
And then a heart tube is
Ventral.
Okay, so blood flow through the heart. You guys have already learned this before. We're going to do it again. You'll have a quiz next week. Y'all should already be pros at this. Okay? So, the direction of blood through the heart. These 9 steps that are listed on here are a little more in detail than what I've taught in the past. We're still going to learn our 13 basic steps of blood through the heart. We'll go over it in here too. So first thing, it says deoxygenated blood flows from the body to the inferior and superior vena cava into the right atrium. Okay, so whenever we're learning our 13 steps, we're going to do vena cava. So vena cava. Now look at your hearts real quick. Coronary artery bypass grafts are not holding up so well here. Okay, so your right atrium is this kind of lighter, for y'all, those it's purple, this is kind of a light pink color. The vena cava are these veins that head into the right atrium. The inferior one, that's from the bottom, like you know, the superior means. Superior comes from like the head and neck and arms. Okay, so it comes, both of those head into the right atrium. Those are the vena cava. Everybody see those? Okay. Second, it heads into the right atrium. That's next on y'all's list. Okay, so it heads into the right atrium. Now this says the right atrium then contracts and forces blood through the tricuspid valve into the right ventricle. So the atria actually contracts, okay, pushes blood through which valve? Tricuspid valve into the right ventricle. Now keep in mind, this isn't, this, as we go through this process, these are not all like independent activities that happen one or, it's not like this whole process. But all this is going on at the same time. The right and left atria contract at the same time. The right and left ventricles contract at the same time. So at the same time, the blood is going from the right atrium towards the lungs. You got blood that's leaving the right ventricle. You got blood that's leaving the left ventricle and headed to the aorta. Does that make sense? So it's all, it's just constantly full. Okay, so we've got the tricuspid valve to the right ventricle. We've got the right ventricle now contracts and forces blood from the pulmonary valve. So it goes into the left ventricle. Got the pulmonary valve.
In the right
Oh,
ventricle.
man.
What did I do? I'm sorry. I had myself there. Sorry, I messed you up, Dawn. Vena cava, right atrium, tricuspid valve, right ventricle, pulmonary valve. Okay, and it heads into the pulmonary artery. And then it goes to the lungs to pick up oxygen. Okay. All right, so oxygenated blood from the lungs travels through the pulmonary veins. Notice it says veins. Okay, look at your heart again. Okay, so let's take our trip so far. So we've got blood that's come in through the vena cava veins, okay, into the right atrium, headed through the tricuspid valve to the right ventricle. Okay, we have pressure against the right ventricle. It pushes blood through the pulmonary valve into the pulmonary artery. Okay, this is in the adult, at least. This is the only artery that you're going to see that's going to be colored blue in the pictures. Okay, why? Only one that doesn't have oxygen. Okay, now it's different in babies and in fetal circulation. We'll look at that, but that's why you don't always want to assume that all arteries are red, and that's one reason, because it's deoxygenated blood. So this goes to the lungs. Okay, comes back through the pulmonary veins. Now, same idea here. Pulmonary veins are red. Okay, there's 4 of them that head back into the left atrium. That's on the back of your heart. Okay, see how there's 4 veins? Those are the pulmonary veins. And they head into the left atrium. And your heart's kind of twisted a little bit in your body, so it kind of looks like the whole left side is at the back. And it kind of is that way, the way it's twisted. Anyway. Okay, so those go into the left atrium. Okay, so number 9, 8 is pulmonary veins, 9 is left atrium. Okay, so from the left atrium, it goes through the what? Yes, goes through the mitral valve. No, I didn't. Okay, so blood goes through there to the left ventricle. Number 11 is left ventricle. Okay, so you're looking through here, and then it pushes back up through which valve? The aortic valve. and into the aorta. Okay, those are the 13 steps. You'll have a quiz on this next week. I think Tuesday is the day I had scheduled it for. Okay, so Tuesday you'll have a quiz. 13 steps. You'll have, you'll get the first one, so you'll get started in the right spot, and you'll have the rest. You'll have the answers, choices to pick from. It'll just be matching, basically. Okay. Those 13 steps.
We're Gucci.
Do what?
What?
What did you say?
I said we're Gucci.
Don't scare me. This, I
Where'd you
really
take it?
like this picture. Really like this picture on 371 in your book. It's really detailed. I like that it shows kind of where all the blood goes through. But I think it helps to hold this in your hand, especially to understand the aortic one, because it's really hard to see in pictures how the pulmonary valve and the aortic valve, where they are and how they kind of crisscross over each other. So I think it helps to have these to look at and hold, you know. All right, the walls of the heart. So you've got basically 3-ish layers that are on the heart, okay, itself. But first, outside of the heart, you have the pericardium. Okay, peri, remember, means around. So this is actually the part that's like, it's really more of like inside your chest. So the pericardium is really like, it's what holds your heart into place. It's connected to the inside of your thoracic cavity. Okay, so within the pericardium, so that I can explain this because you may not be able to see it on your PowerPoint because it may be too small.
Yeah.
But you can see it on page 372 in your book. Okay, so you've got this outer fibrous pericardium that's attached to the inside of your chest cavity. Okay, it's really fibrous. And then inside of that, okay, you've got what's called the parietal pericardium. Where have we heard the word parietal? Do what?
Oh,
Oh, yeah. That's not what I was thinking, but okay.
okay.
Well, parietal and visceral, those two.
Yeah,
The lungs. Okay, remember the double layer of lungs, the double lining around the lungs? You have the parietal and the visceral.
Oh,
Okay, same idea with the heart. It's got a double layer membrane that has serous fluid between those two layers, just like the lungs. Why does it need that?
it's love.
Yeah, so it can move. I mean, your heart is moving, even though it's in like a stationary spot. Same idea with the lungs. It has to be able to move to be breathing out. Same idea here. It needs to have that movement. So the parietal pericardium is the outer layer of that that's attached to the inside of the thoracic cavity as well. Then you have that little serous cavity in the middle. Then you have the epicardium, which is also called, this is the serous pericardium, but visceral pericardium is what I've always heard it called. Okay, so that's also known as the epicardium. So that's what I want you to, whenever you look at this, the epicardium is really just one layer of the pericardium. So that's the outermost layer of the heart itself. Okay, is the epicardium or the visceral pericardium. Then you have the myocardium, which is the middle. Myo means
Muscle.
muscle, not a big old muscle. So myocardium is the thickest part, thickest layer of the heart, and you can see it pretty well on your little models there. So it's thicker in some places than others. Notice it's thicker on the left side than it is on the right side. Why do you think that is?
Say what?
Why do you think the muscle is thicker on the left ventricle than it is in the right ventricle?
Because it's sending out all of that oxygenated blood to the whole body.
Right. The left side is going to the whole body. Where's the right ventricle sending blood? Just to the lungs. It's not very far away. Okay, they say if you were to lay your heart down on the ground and let it pump, it would pump blood like 30 feet into the air.
Yeah.
So that's how powerful
That
it
is
is.
cool.
Right now.
And that all comes out of the left ventricle.
Volunteer.
So then we have the innermost layer is the endocardium. Okay, we know endo means
Inside.
inside. Okay, we've heard all these terms. So endocardium is the inner layer. Now the endocardium is pretty specialized. It's an epithelial layer. Okay, there's no gas exchange that's taking place here. Your heart does not get its own blood and oxygen supply from the blood that's inside of it. That's because this layer, the endocardium, it's kind of a filmy type of really slippery, epithelial tissue that allows for blood to move easily, but it doesn't absorb nutrients from the blood that's in the heart. That's not its purpose. How does your heart get blood? I should know this too from last year. Where did my heart go? How does your heart muscle get its blood and oxygen supply? All the arteries and veins on the outside. Okay, so if you'll look at like the crack of where the aorta meets the top of your heart, there's a little artery that comes off of there. Y'all should have it.
Oh, right.
I knew that one had it.
Right.
Yes, that's it. You see it? Right here. So, they put the front one there.
Found it. Well,
Okay, that is how your heart muscle gets its oxygen. It gets it from the outside. Okay? Now, this being so close to the base of the aorta, this is one of the reasons that you especially get plaque buildup and fatty buildup in those blood vessels around your heart that cause coronary artery disease, blood clots. That's why people have to have bypasses, all that kind of stuff, because that blood vessel that feeds the heart muscle is just right there. So that's kind of like the first place for all that stuff to go. Okay, so anyway, so that's endocardium. That's part of its purpose, is that it has that filmy layer in it, but it doesn't allow for gas exchange. Otherwise, your heart would use up all of the oxygen before it ever pumped it to the body. That makes sense? That would be that. Okay. All right, the cardiac cycle. So diastole, y'all have heard these terms before. Where have you heard about systole and diastole?
pressure.
Blood pressure.
Diastolic.
Yes, systolic number is the top number. That's the most pressure. Diastolic is the bottom number. That's the pressure on the arteries when the heart is relaxed. Same idea here. So dystole is when the ventricles are relaxed, okay, and the atria contract. Systole is when the ventricles contract and the atria are relaxed. So they work, it just like pumps kind of like this. Okay. Mean arterial pressure, this is the overall pressure within the cardiovascular system. There's constantly a pressure there. Otherwise, go anywhere. Heart wouldn't be able to go anywhere. Okay. Cardiac output. Almost done here already. Make sure I didn't miss something there. No. Okay, cardiac output. This is the amount of blood pumped by the heart in 1 minute. Okay, this is what we consider what we call the cardiac output. Like whenever they say, okay, they've increased the cardiac output and the cardiac output is decreased. Talking about the amount of blood pumped by the heart in 1 minute, measured in liters per minute. So it looks at two things. Stroke volume, okay, which is the amount of blood pumped in one pump, or one beat. How much blood is actually the volume of blood that's leaving, plus the heart rate, so how many beats per minute. Okay, so if you affect either one of these, it's going to affect cardiac output. And you'll find that they'll kind of try to make up for each other. Okay, so if one starts falling down, the other one will pick up. And you can literally
Bless you.
figure this out. It's just your cardiac output is just stroke volume times your heart rate. That's the formula for how to figure out cardiac output. CO, you'll see it. Where it is, CO. Okay. How much blood your heart can put out in 1 beat times the number of beats. Makes sense. Okay, so that's it. That's the anatomy, at least, of the heart itself. So kind of a review from last year. We learned a lot of that last year. And we learned about several diseases last year too, so that'll be a review for a lot of you guys.